Good evening, everybody, and welcome to another online review session in organic chemistry. Before we start the session today, I do want to let you know that we are going to use the questions from our chapter 3, which will be the end of chapter 3 questions. But before we do that, let me go ahead and acknowledge those of you who have already joined us. I see Amber Emerson, Area Waller, Brandon Johnson, Brianna Neal, Siobhan Cummings, Chandra Pretty, Gustin Adejumo, Ines Kufando, Dine Jones, Kiera Bradley, Lorena Head Williams, Mecca Islam, Oyin Olusheye, Sandra Onyegere, Spencer Mitchell, Thomas Obisheson, and Tiffany Farrell. You are all welcome to today's session. Okay, to get the session started, we do have a lot of material to cover. Hopefully, we should be out of here within the next 1 hour. Olusheye, go ahead and read this question for us.
Identify the functional groups of the substance above.
Okay, very good, and thank you. Okay, what they want us to do is to identify the functional groups of the substance above, and of course, that substance is this molecule here, as you can see. So this question is essentially testing your knowledge of the functional groups or the classes of organic compounds. And as I told you earlier in class, your textbook sort of mixes functional group with classes of organic compounds. So when they say functional group here, they actually are referring to the classes of organic compounds. Okay, so if you take a look at this molecule, we see here, this is the carbon-oxygen double bond. Okay, we call this the carbonyl group. And of course, we also have this group right here, which we call the ester group. And this group here, which is oxygen attached to carbon and another oxygen attached to another carbon. Does anybody know what that group is referred to? What class of compound is that group referred to? Anybody has an idea? Okay, let me give you some help. The question is, they want us to identify the class of compound that is here. I must confess that they do not have too many classes of compounds here. So, based on what we have just given you, what class of compound is this here? Okay. Yes, that is correct. This is an ether. This is an ether. Somebody just asked me a very important question. He said, do we need to memorize all of these classes of compounds? Unfortunately, yes. And that is why I took my time to go through all of those classes of compounds. You need to be able to recognize them, to identify them if we give them to you. Okay, so this here is an ether right here. So what class of compound is this? What class of compound is this? This here. Okay, similar is, okay, no, that is not an aldehyde. Keep, one more try. Okay, no, that's not the carboxylic acid. You are close now. You are getting close. Ester, exactly. This is an ester. You see, you have the carbonyl attached to carbon here, and then this carbon is attached to oxygen, and then this oxygen is attached to a carbon atom. So you have two functional groups or two classes of compounds in this molecule. You have an ester, you also have an ether. Okay, so let us go to the next question. Okay, this question here, Kiera, go ahead and read this question first.
Give the IUPAC name for the following alkane.
Okay, very good, and thank you. Okay, what you want us to do here, give the IUPAC name for the following compound. If you look at this here, it looks almost like a monster, but it is a very simple molecule indeed. So what I'm going to do, I've already copied this into my notebook, because what they're giving you here, they're giving you this molecule here using the stereo structure. Stereo means three-dimensional structure. So let us go to my notebook, and then we'll look at this molecule in 2 dimensions, and then write the IUPAC name. So give me 1 second. Okay, let us see here. Okay, this molecule here. So I am going to go ahead and write the 2-dimensional structure here. Okay, if you look at this molecule, starting from this carbon right here, starting from this carbon, we go to this carbon, to here, here. If I ask you, what is the longest carbon chain in this molecule? What is the longest continuous carbon chain in this molecule? Anybody has an idea? 6. Excellent, excellent. Okay, so let us start writing this. I'm going to start from this carbon right here. So I say we have CH3 attached to a CH2. See, when you write this in 2 dimensions, it's much easier to see. And that CH2 is attached to another CH2. And this CH2 is attached to a CH right here. And the CH is attached to an ethyl group and also another ethyl group. So 2 ethyl groups. Another ethyl group. Okay. Can anybody now give us the IUPAC name for this molecule? You already told us the longest carbon chain is hexane, which will be the base name. So what would be the name? Okay, somebody said 3-ethylhexane. Is that correct? Let us see. Great, great. That is great. So I'm assuming that you guys want to start your numbering from here. 1, 2, 3, 4, 5, and 6. And that is correct. The name is 3-ethyl. Hexane. So what you need to do here, whenever you are giving molecule in 3 dimensions, just as you have here, to make it easy for yourself, go ahead and write out the molecule in 2 dimensions, just like I have right here. That way it is much easier to see. Okay, this is the 2-dimension. That 2-dimensional look of the same molecule. Okay, and this is 3-ethylhexane. So I think everybody got that right. That is correct. Now, if this is clear to you, give me a happy face. Okay, good, good. Okay. Now, what I want to do now, I want to go back to this question. This question, I actually took this from Al. Okay. Gosin Adejumo, can you go ahead and read this question for us?
Identify the functional groups of the substance above. Use the name from the table below. If there are fewer than 3 functional groups, leave an I don't know what that is. Yeah.
Okay. Yes. No, that's fine. That's fine. Thank you. Okay. Now, what they want us to do here, just to identify the functional group. Unfortunately, I do not have the table of classes of compounds that we went through earlier. So, but based on what we gave you earlier in terms of the different classes of compounds, can you identify the classes of compounds here? Let us start with this here. Take a look at this. What class of compound would this be? Anybody has an idea? I will give you, okay, that's carboxyl group. Carboxylic acid, excellent, excellent. Actually, you know, if you think of the functional group is called carboxyl group, which is correct. And the class of compound is carboxylic acid, just like you guys already told us. Okay, very good. Now let me take that off. Okay, now can anybody identify this class of compound right here? This class of compound right here. What class of, okay. No, exactly. Arene, that is correct. That is arene, that is correct. Very good, very good. Okay, so far so good. Now can anybody identify this class of compound? This class of compound right here. Keeping in mind that this is nitrogen. The blue is nitrogen. Okay. Yes, amine, very good. Very good. That is amine. Okay, very good. Now somebody asked me a question through the chat window. Let me go back to that question. Where's that question now? You see, are aromatic rings and arenes the same? Yes, you are correct. Aromatic rings and, well, to some extent, not all aromatic rings are arenes, but aromatic rings in which you only have carbon atom in the ring system, yes, they are considered as arenes. Okay? Okay, so that is good. Now let us now go to okay, can anybody draw the skeletal structure for this molecule? What would be the skeletal structure for this molecule here? Before you do that, let me ask you, what is the longest carbon chain in this molecule? 4, exactly. That is 1, 2, 3, and 4. Okay, so therefore, you have branches in position number 2 and also another branch in position number 2. So you have 2 methyl groups attached to carbon number 2. So therefore, what we have here, so that would be this here, this here, this here. 1, 2, 3, 4. So you have carbon number 2, have methyl and methyl. And that would be the skeletal structure for that molecule. Now, can anybody give us the IUPAC name for this? 2,2-dimethylbutane. Excellent, excellent. 2,2-dimethylbutane. That is great. Okay, so you guys are rolling tonight. Okay, great, great, great. Everybody got that right. Okay, so let us go to the next one. Okay, this we will do in class tomorrow, so let us keep this for now. Okay, this is a very interesting one. Lorena, go ahead and read this question for us.
Draw the structure of the isomer of C7H16 that contains 3 methyl groups.
Okay, great. Okay, so they want us to draw the isomer of the molecular formula of this compound is C7H16, and they say that it must contain 3 methyl groups. Now, this is the question I have for you. If they have given us this formula here, which is, in other words, this molecule contains only 7 carbon atoms, and now they have restricted us to a molecule that has 3 methyl groups as substituents or branches. What do you think will be the longest carbon chain in this molecule? 4, exactly. Because they've already told you you have 3 methyl branches, so therefore the longest carbon chain has got to be 4. So let us do that. Okay, so that would be the base name. Now we want to remove the hydrogen. Keep in mind, most of what you have been tested for here is your knowledge of valence, octet rule, and of course nomenclature. So we place one hydrogen, one methyl here. Okay, let me number this carbon. This 1, 2, 3, and 4. Okay, so I want to place another methyl group here because they say that it must have 3 methyl branches. Okay, folks, now I have a question for you. I have one more methyl branch to go. Where will it go? Where should I put the methyl branch in order for us to meet the requirements of this question? Position, okay, position 2 and 3, that is excellent. Excellent. Position 2 and 3 is correct because you cannot place it in position 1. If you place it in position 1, then the longest carbon chain will be 5, not 4. Okay, so that is correct. So therefore, I will take one of these out. I will then place this right here. Okay, so that is the molecule that they want us to draw. Can anybody now give us the name of this molecule? What would be the name of this molecule? Two, 2,2,3-trimethylbutane. Excellent, excellent. You everybody got that right. You got to show all of the, for each branch that you have, you got to indicate the position, the number at the position of that branch. So in this case, you have 3 branches here. So you have, in 2 positions, you have 2 of them. So it has to be 2, 2, then you have another substituent in position number 3. Then you say 3. Then it becomes trimethylbutane. Now, do not make a mistake. Some students will make a mistake because they say, well, since on the 2 positions you have 2 methyl groups, you only show only one of the two. No, you have to show both of them, because this says that you have a methyl here, another methyl here, then methyl in the 3 position. You cannot say 2, 3, tri-methyl. No, you cannot do that. This would be wrong. This is wrong, okay? Okay, very good. Now, supposing you have to write the skeletal structure for this, what will it look like? Of course, the skeletal structure will simply be 1, 2, 3, 4. That is 4 carbon. And on the 2 position, you have this here, and on the 3 position, you have this. That is the skeletal structure. Okay. Let us move on. Now, okay, this question here simply points at one aspect of organic molecules that we discussed in our last lecture, which is the constitutional isomers. Constitutional isomers. You notice what they tell you here, that using this formula here, you have 9 constitutional isomers. I would simply ask you, when you have the time, when you go home tonight, go ahead and write out all of those different constitutional isomers. Okay? Okay, let's go to the next one. Okay. Okay, I think I've called on all of those students that I think their minds are working. But if your mic is working and I have not called on you, can you please pick up the mic and read this question for us?
Draw the structure of the branched alcohols with the chemical formula C5H12.
Excellent. That's the me or Shundeko. Very good. Okay. Somebody's talking about quiz tomorrow. Okay. The question here is, draw the structure of the branched alcohols with the chemical formula C5H12 and 1 oxygen. So once again, we are dealing with constitutional isomers. That is what they are testing here, your knowledge of constitutional isomers. Even though we are actually focusing on alkanes and cycloalkanes in chapters 3 and 4, very often they will bring in some other classes of compounds. So here, they want the branch alkane with that formula. So what do we have? We have 5 carbon atoms. So CH3. Keep in mind the key here is branch. CH2. Okay, CH. Okay, how many carbons have I used so far? 1, 2, 3, 4. One more carbon to go. Say CH2 and an alcohol. In other words, they want to know whether you know what an alcohol is. Keep in mind, an alcohol is an hydroxy group. Hydroxy group attached to a carbon atom. Okay? Now, supposing I ask you, what type of alcohol is this? Is this primary alcohol, secondary alcohol, or tertiary alcohol? Does anybody know what type of alcohol is this? Primary? Primary, yes. It is a primary alcohol. It is a primary alcohol because the hydroxy group, this oxygen here, is attached to a primary carbon. Keep in mind, a primary carbon is that carbon that is only attached to one other carbon atom. So this is a primary carbon. So therefore, we refer to this as a primary alcohol. Now, supposing I ask you to use this same formula here, C5H12 with 1 oxygen, to give me or to write a secondary alcohol, what will it look like? I ask you to write for me a secondary alcohol using this formula. What will it look like? Okay, let us take this off. We want a secondary alcohol. Okay, so I could very well do this. Keep in mind the secondary alcohol is what? What is a secondary alcohol will be attached to a secondary carbon. And what is a secondary carbon? That is the question you need to ask yourself. What is a secondary carbon? Does anybody know? Carbon that is attached to 2 other carbons. Exactly. In other words, what I am going to do now is to arrange this molecule here so that I have the oxygen is attached to a secondary carbon. So let us do that. How many carbons do I have? I have 5 carbons to use, so that becomes that. Okay, how many carbons? 1, 2, 3, 4, 5. It is C5, so we have the formula that we need, and we have the hydrogen in place. So this is a secondary alcohol. This here is a secondary alcohol because the hydroxy group is attached to a secondary carbon. Okay? Now, supposing I ask you to use the same formula to write for me a tertiary alcohol, what would that look like? So maybe the question I need to ask you is, what is a secondary carbon? What is a secondary carbon? I'm sorry, tertiary carbon. Because at this point I wanted to write exactly. Tertiary carbon is bonded to, it's a carbon that is attached to 3 other carbon atoms. So therefore, if I ask you to write a tertiary alcohol using this formula here, you must show me a molecule in which you have the hydroxy group must be attached to a tertiary carbon. Okay, how many carbons do we have in this molecule? 1, 2, 3, 4, 5. So you see here, using the same molecular formula, now we have, let me take this off. Using that same molecular formula, we have primary alcohol, tertiary alcohol, and finally we have a secondary alcohol. Now, this is the question I asked for you. What is the relationship between all of these 3 alcohols? What is the relationship between all of these 3 alcohols? What is the relationship between them? Keep in mind they all have the same molecular formula. They are all constitutional isomers. Exactly. Excellent. So all of these are constitutional isomers. You notice what have we done here? Constitutional isomers are simply different molecules with the same molecular formula, but different attachment of the atoms. If you look at each one of these compounds here, the attachment of the atoms are different. Okay, and that is what makes it. Okay, you say you do. Now, can you pick up the mic and tell me exactly what you don't get? Somebody said, I don't understand that. Can you pick up the mic or type to me in the chat window? The center carbon is attached to 3 other carbons. This here, is this one here?
Professor, what
right?
makes it constitutional?
Okay, constitutional isomers are different molecules, okay? If you look at each one of these here, these are different compounds, because if I ask you to give the names, they are going to be different compounds. So constitutional isomers are different compounds that have the same molecular formula, but the difference between them is the way the atoms are arranged or are attached to each other. This atom, this molecule here, if you look at this, the way the atoms in this molecule are attached is different from the way the atoms in this molecule are attached, even though they have the same molecular formula. Therefore, we say this compound and this compound are constitutional isomers. Okay? Okay, so very good. So anyway, so constitutional isomer, we are going to be discussing a lot of this during the course of this semester. So this question actually does help us to further expand on that concept of constitutional isomers. So let us go to the next one. Okay, this will be a good one. Okay, can somebody pick up the mic and read this for us?
Draw the structures of 4 esters with formula C4H8O2.
Okay, very good. That's Kiera Bradley. Very good. Thank you. Okay, so what they want us to do here, draw the structures for 4 esters with formula C4H8, C4H8, and 2 oxygen. So what they are testing here, whether you know what an ester is. Okay, so we only have 4 carbon atoms. Let us give it a try. We have, in other words, they want to know what an ester is. An ester is that molecule in which you have a carbon-oxygen double bond. It's attached to a carbon atom, and that carbon-oxygen double bond is also attached to oxygen atom, and the oxygen atom is in turn attached to a carbon atom. So you could have this. Keep in mind the formula they have given us. You have to use this formula here. Okay? So this molecule that I have drawn here, is this an ester or not? Yes or no? Yes, it is an ester. Okay, it is an ester. Okay, because what we have carbonyl attached to oxygen, and the oxygen is attached to a carbon atom. Now, they also want us to draw 4 of these 4 esters. Let me do another one. Supposing I have this. Supposing I have this. Okay, is this an ester or what? Yes or no? This one here. Let me call this A. Let us call this B. Is molecule B and A? Yes, it is an ester. The same thing. But notice what we've done here. All we're doing is attaching the atoms differently. So therefore, if I ask you between these 2 esters, A and B, what is the relationship between them? What is the relationship between these 2? Keep in mind they have the same molecular formula. What? Constitutional isomers. Now you see the concept of constitutional isomers. It is a very important concept. Okay, so this ester A and ester B, they are constitutional isomers. Yes, we are supposed to draw 4 structures. Yes, that's what they asked you to do. We have not finished yet. So compound A and compound B are constitutional isomers. Okay, so since they asked us to do 4, I'm going to do another ester. We have this here, could be this. Okay, look at the formula we have. The formula we have is C4H8 2 oxygen. This molecule here fits that formula. Notice again, this is an ester. You have carbonyl attached to oxygen, and that oxygen is attached to a carbon atom. This is another example of an ester. So let me call that molecule C. So what is the relationship between molecules A, B, and C? What is the relationship between them? They are all constitutional isomers. You notice what we've done? The attachment or the arrangement of the atoms are different, even though they have the same molecular formula. And that is why we have a branch of chemistry called organic chemistry, because carbon atoms, you could draw billions of molecules using carbon atoms joining to each other because of the possibility of having constitutional isomers. And as we go forward, you will also see some other types of isomers. But for now, let us stick with these constitutional isomers. Okay, so far we have 3. One more. I could also add this. So you have to use your own ingenuity to see what kind of arrangement you can write that will meet the requirement of the particular problem. In this case, you have to draw 4 esters. The only thing that you have to concern yourself with is that you must obey the valence rule and also obey the octet rule. Okay, so you have this. Supposing we have this. Supposing we have this. Supposing we have this. This is another ester. Okay, this compound here is also another ester. I will call this compound D. So you now see here, we have 4 compounds that we could write, all of which represent esters coming from this formula right here. Okay? And all of these structures, therefore, the relationship between them, they are all constitutional isomers. Okay, keep in mind the definition of constitutional isomers. Again, they must all have the same molecular formula. That means you have different compounds having the same molecular formula. The only difference between them is that the attachment of the atoms or the arrangement of the atoms within the molecules will be different. Okay, that is how you read. That is how you arrive at having constitutional isomers. Okay, let us go. Now, if that is clear to you, give me a happy face. You see here. Okay, I see a bunch. Okay, very good. I think we have 15 more minutes to go, because definitely I want us to get out of here by. Okay, this question, I will come back to this question. Okay, let us do this one here. Let me see here. Okay. Can somebody pick up the mic and read this question for us?
Draw the structure of an alkane that has 6 or fewer carbons. Draw the structure of an alkane that has 6 or fewer carbons and does not have secondary or tertiary carbons.
Very good, and thank you. That's Mariah Sankey. Very good. Okay, so what they want us to do here, draw the structure of an alkane. It must be an alkane that has 6 or fewer carbons that does not have secondary or tertiary carbon. So what they are testing here, whether you know what the different types of carbons are. Whatever you draw here must not contain secondary or tertiary carbon. So you could use any molecule that contains 6 carbon or less. Okay, so if that is the case, let us say keep in mind no secondary or tertiary carbon. Supposing we then say, because that means that you must only have primary or quaternary. That is what they are essentially telling you. The molecule must only contain primary or quaternary. Keeping that in mind, I would say, okay, if that is the case, I could have this. So your own ingenuity is what will guide you here. Okay, you are free to write any molecule as long as it contains 6 carbon or less. Is that right? Okay, let us see here. Okay. Okay. What is the molecular formula for this molecule? Anybody know? How many carbons do I have here? Okay. Oh, somebody is giving me the name. Great. 5. So it meets the requirement. They say we could use 6 carbon or less. Now, what types of carbon do we have in this molecule? What types of carbon do we have in this molecule? Primary and quaternary. Exactly. So we answer the question they want us to answer. So this is primary. Of course, this is primary. And this is also primary. And of course, this here is your quaternary. Okay? So that is what they want us to do. Write a molecule that only contains primary and quaternary carbon atoms. And of course, the primary carbon is those hydrogen that are attached to the primary carbon. They are referred to as primary hydrogen. So all of these are primary hydrogen. Okay, let us move on. Okay, somebody read this for us.
Methyls have changed.
Yeah, go ahead.
Draw the structure of 4 isopropyl and 3 methylheptane.
Okay, that's Mecca Islam. Okay, thank you. Draw the structure of 4 isopropyl methylheptane. Okay. So what is the base name? How many carbon in the base name for this molecule? How many carbon? 7. Okay. So let us go ahead and do that. So we have. I like to do this because I want you guys to see how to keep track of your valence. By doing this, you will be able to keep track of your valence. So if you have any substituent, you know you have to remove 1 hydrogen before you attach the substituent. Okay, so this is an heptane molecule. And then they say in the 3 position you have methyl. So I have to remove. Now do not make a mistake of simply just adding methyl to this. In that case, you will be violating the valence rule and the octet rule. So remove the hydrogen and then place the methyl here. Okay, now they also now say we have isopropyl. Okay, so far you guys know what a methyl group is. You also know what an ethyl group is, but I don't think I've shown you what an isopropyl group is. So this here, this group a CH group attached to two methyl groups, this is called an isopropyl. So this is a fragment. This fragment here is an alkyl fragment. This is called an isopropyl. So keep that in mind. Anytime you now see isopropyl, you know what it looks like. Okay. So now they want 4 isopropyl. So that means we take one hydrogen out of here, and now we place an isopropyl group. That is the isopropyl. Okay. If you follow that, okay, give me a happy face if you follow that. Okay. Okay. Now, supposing I ask you to write the skeletal structure for this compound. Supposing I ask you to write the skeletal structure for this compound, what will it look like? The skeletal structure, let us see. We have 7 carbons, so let us go ahead and write the 7 carbons here. Use a green. Okay, let me start with this. Carbon 1, 2, 3, 4, 5, 6, 7. That's 1, 2, 3, 4, 5, 6, 7. Now let me write this up here so that I have room to put my branches. Okay. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. So in position number 3, I have methyl in 3. Position number 4, I have isopropyl. Okay, and that will be the skeletal structure. Somebody asked a question. With questions like this on how, are they going to ask for the formula or the skeletal structure? Well, they could ask for anything. They could ask for anything. The reason why I bring all of this up, don't forget, this is a review, so I want to bring as much of the concept to solving this problem as possible. Yeah, they could tell you to give the formula. Okay, supposing I ask you to give the formula for this compound. Okay, yeah, let's do that. Supposing I ask you to give me the molecular formula for this compound. Okay, can you do that? Let us do that together. Give the molecular formula for this compound. Okay, we have 5 more minutes to go. Give the molecular formula for this compound. Okay, I'm waiting, give you guys a few seconds to do that. C11, is that right? C11H24. Okay, I hope that is correct. Okay, so all of you said, so I'm going to take your word for it. That is 7. This is plus 3 carbon. That is 10. So C11 is correct. Yes, I think that is correct. Okay, that is correct. C11H24. Okay, let us see here. Okay, let us do this problem and then we call it a day because I do not want us to go beyond 9 o'clock. Okay, somebody read this question for us.
Give the IUPAC names for the following compounds.
Okay, that's Ines Kifando. Yes, thank you and welcome. Okay, give the IUPAC names for the following compound. Now, folks, what they've given you here, they have given you what are called super condensed structure. I do not want you to write your structure like this because you may confuse yourself. Okay, so now let us give this structure. Before we actually give the IUPAC name, if you are given a structure like this in which it is super condensed, I will write it out in a semi-condensed structure. Okay? Okay, so let me focus on this carbon here. If you look at this carbon here, what they are telling you by what they've done here, this parenthesis here, is that these 3 methyl groups are attached to this carbon. That is what they're telling you. So that is this here. That is why I don't want you to write your structure this way, because you may confuse yourself. So that is this carbon right here, right here. Now that is now attached to this carbon here. And that carbon now, they are also telling us that carbon is attached to 2 methyl groups, okay? So I have this here. They are telling us that carbon is attached to 2 methyl groups. And now, this carbon now is also now attached to this carbon, which is a CH2, another CH2, okay, so what we've done now, we have written this super condensed structure in a semi-condensed structure. In this form, it is much easier for you to give the nomenclature. Can you give the nomenclature for this, the IUPAC name for this? What will it be? The first question you need to ask yourself is, what is the base name? And where do you start the numbering? Do you start the numbering from here or from here? I will start the numbering from here. Okay, start the numbering from here. That way you get the lowest. Okay, great. Oh, you guys got them already. Okay, so that is 2, 2, 3, 3, tetra, excellent. Tetra, methyl, you have 4 methyl group. And the longest carbon chain is hexane, yes. Okay, because this is carbon 1, 2, 3, 4, 5, and 6. Okay, so we got that right. Excellent. Very good. You guys are doing just fine. Okay, I think we could move on that. I agree with the consent. Okay, good. Now let us do this and then we leave for today. I think it's almost 9 o'clock. Let me erase this. It's 1 minute to 9, so I promise you guys we are going to be out of here. I want to respect your time, so we are going to do this now. Okay, so what I want to do now, let me, just like we did with this one, let us write the semi-condensed structure, focusing on this carbon here. Okay, this carbon here, what they are telling us, that this ethyl group, we have 3 of them attached to this carbon. That is what they are telling you. So you have and then you have this here. And now that carbon is attached to, oh sorry, this carbon now is attached to this carbon, CH2. So let us draw that. And then attach to another CH2. And now this carbon here, that CH2 is attached to this CH. And that CH is attached to a 2CH3. Okay, now the question is, Well, the question is, what is the IUPAC name for this? Let us do this and then we call it a day. What is the IUPAC name for this? Okay, the first thing you need to ask yourself is, what is the longest carbon chain? Okay, so you are calling this hexane, octane. Let us see. Let us number it. Okay, I will say, let us see if we can start numbering from here. 1, 2, 3, 4, 5, 6, and 7. Okay, so therefore it is an heptane. Okay, very good. So therefore, will somebody say 3,3-diethyl 6,6? Would that be correct? Okay, 3,3-diethyl. Okay, 3,3-diethyl. Because of the ethyl group, ethyl comes before methyl, and then 6 methyl, heptane. Okay, do we agree with that? Yes, yes, okay. I think everybody agree with that. Okay, great. Where the C in front of the second CH2? Where the carbon in front of the second CH2? Where is that? Let me see. The carbon in front of the second CH2. I don't see. Which carbon are you referring to? We have this here. Anyway, so this is the name of this. This is the name of this structure right here. 3,3-diethyl 6-methyl heptane, because you have the 3 ethyl group attached. I'm sorry, you have 2 ethyl group attached to this carbon here. This is the longest carbon chain. This here. This is the longest carbon chain, which is 7, and of course this means that these are the branches. These are the branches. This here, and this here, and this here. So you have 3 branches. Okay, folks, we have come to the end of. Oh, somebody say, why wouldn't you count from the? Yes, go ahead. Somebody say, why don't we count from this other carbon here? Okay, that's a good question. So if we counted from here, let us do that just for the sake of this discussion. 1, 2, 3, 4, 5, 6, and 7. If we do that, then the branches will be in positions. The branches will be in position 2. This is position 2. And then you have this here, the 2 ethyl group in position 5. So that's 5 and 5. So what do we have here? Oh, wait a minute, wait a minute. You know what? I'm looking at this here. You may have something here. You may have something here. Okay, let me take that back. Oh, I am glad you asked that question. You may have something here. If we have that, okay, very good. So that could be, okay, this is wrong. Okay, sorry about that. So therefore, if we have that, I'm glad you asked that question. That's an excellent question. Okay, so if you have that, so you have, what we have here, we have 2 plus 5. Oh, no, 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 that's not right. No, 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 that's not right. That's 5 plus 5, that is 10, plus 2, that is 12. It is this, as opposed to 3, 3, it's the same number. Okay, very good. Okay, okay, now this is a very important question. Actually, the name that we have, 3, 3, I think this is correct. I will tell you why. Diethyl 6-methyl heptane. Okay, you bring up a very good question. This is correct because if you add 3 plus 3 plus 6, it is 12. If you add 5 plus 5 plus 2, is 12. But in this case, if you can go from either side and the assignment of numbers are the same, then you've got to give priority to the alphabet. In this case, the ethyl comes before methyl. So therefore, you have to start counting from the side where you have the ethyl being the lowest possible number. So that's an excellent question. So anyway, so in this case, this is the right answer here. This is the right answer, but this is a very good question though. Keep in mind, whenever you have a choice, and the two choices give you the same numbering system, then you have to go for the alphabetical order. In this case, you go for the ethyl in this case. Okay, folks, we have come to the end of this session today. Those of you who want to stay back for another 5 minutes, I'm going to turn off the recorder. And if you want to stay for another 5 minutes and just ask me a few more questions, you are welcome to do that. So until we see you in the class, enjoy the rest of your evening.